Alright, so this is the scripting involved with my top-down chip. I'll go ahead and just demonstrate what it does right now. So this is my wired numpad input, and it's set to 8 on my numpad. So when I press 8, everything activates. As you can see, the camera becomes top-down. The player starts to move. W now corresponds to up, and S to down, and left and right, rather than, traditionally in Source, W is forward where you're facing. So now it's forward as a whole, as top-downs need to be. Because I couldn't get a reticule up on the screen to where the player was aiming on this 2D plane, rather I have opted to put this little red bar for a sort of laser sight, as to better tell the player this is where your bullets will be going. And this has worked out very well so far. So I'm going to go ahead and go over what all this does. So first is the wire camera controller. This is essentially just a camera. You just don't place it like up in the air. You have to tell it where to be. So I'll go ahead and go over how I managed that. So the first thing we need to have is this target finder beacon. What the target finder does is it's going to place it down. It has a range at which it looks for things. You see here minimum range, maximum range, and there's a lot of different things that you can look for: players, NPCs, props, specific props that you want. And so we have it looking for players specifically. And so because this is only set to a single player level, it'll just look for the regular player, but you could even have it filter by player name, entity name, so it would be like player_1, or even Steam ID, though I've never used the Steam ID to see how well that works. So this target finder, on this target finder we have the max cranked up to larger than it will ever need to be, so it will always know where the player is. It'll always have the player in the target finder. So next we have, so this is the simple numpad input. Activates when you press 8 on your numpad. So we have activated on the wire camera controller linked to 8. So when 8 happens, this camera controller is going to happen. So to tell the camera where to be, these are all the different options you have. You have direction vector, angle, position, distance. You can even parent it, which I won't explain that. You can filter out entities of what to display and what not to display, all manner of things. So our position is going to be the position of the player. However, the target finder itself does not output the player's vector. What we have to do is we have to have a beacon sensor that we will tell output its world position. So as you can see there's the world position. However, that isn't quite the format it needs to be in. So what we have is this compose chip, and what this composes is the X from that, the Y from that, and so on and so forth, so that is going to take the individual X, Y, and Z numbers and compose it into a vector for this position to have. But on top of that, as that would set up, it would have the camera right inside of the player. So what we have to do is we have to take this add chip, which takes, I believe it's the X value from this world position chip, or the world position from the beacon finder, and it adds 500. It's the third value there. It adds 500 to it, meaning that it adds 500 to the vector of the z of the vector, meaning it's 500 units up from where that beacon sensor says the world position is. So it takes the player's vector and is 500 up on the z. And then on top of that, it has the angle, which I guess these not all wires always have this solid line to them. Like these two are for sure wired, but they just don't have the visual indicator to them. But the angle is set to the 4 value, which is 90, 0, 0, because angles, like vectors, need to have 3 numbers to them. So that angle puts it at a 90-degree angle from the 0, 0, 0. That would be the player looking straight forward. So it takes it 90 degrees and turns it to where it's this down angle. So not only is it 500 units above the player, but it's looking down at a 90-degree angle. And now we have a down-facing camera that follows the player at a certain height. And if we wanted to edit it, it would be as simple as taking the constant value chip, copying the numbers. Let's say now we want it at not 30, 300. Now it's much closer. Or 700. So doing it like this keeps it very easily edited. I don't go into coding until I absolutely have to later, because I am just more comfortable with this visual system. So what's next is, I believe that's all for the chips. Next we have to go into the actual expression chip itself. So this is where I've started actually coding things in. So the name of the chip is the top-down chip. These are all of the inputs it has. So when you go to wire it, these are its wire inputs. So it can, so it has the player input, which corresponds to an entity, the stick input, which corresponds to another entity, and the active input, which corresponds to a number. And these are wired such that active is wired to the 8 button. Once again, the player entity is wired to our target finder. The target finder tells the chip, this is the player I'm looking at. Ooh. Go ahead and get this back to what it needs to be. And so the stick entity is hooked up to an advanced entity marker. So what the entity marker does is similar to what the target finder does. The target finder locks on to the player. This entity marker is going to be locked on to our stick here. And so it has one entity linked to it. So our stick is linked to entity 1. So it knows that the stick entity is that entity, which is the first in the array. Hope that makes sense. So now that we've established what all 3 of those are, we have if active 1, so when the chip turns on in that area. Oh, I also forgot to mention that the way the camera works, it locks the player into looking at a certain angle and rotating from there. You can't aim up and down because, obviously. And so what this accomplishes is having it at this downward angle rather than straight forward means that your bullets do eventually hit the ground because you are aiming slightly at the ground. And then later on, I can go in and tell it when you equip the shotgun, aim it down a little further so that the shotgun is a lot closer to you. And so, yeah, that's the other one thing I forgot to mention that we'll go over in the code. So, the angle is the player entity, and the function iAngles, which is basically where this entity is aiming, and the entity is player, so angle equals where the player is looking. We have clamp angle, which is the clamp feature makes it to where this angle cannot go below 0 or above 20. So we have it set. I'll just come back. I'll skip over the stick for now. We have it set to where player set angle is angle 10, which corresponds to how far up and down. Angle yaw. Oh, I guess I ended up not even using clamp angle. So, I suppose it's just that makes sure this is at 10. So what this clamp angle would do, I remember now, is if I were to incorporate this would allow the player to look up and down between angles 0 and 20. But I decided not to use that and rather to just lock it at 10. So that's what that does. So we have this function that is constantly calling that sets the player's eye angles to 10 on the pitch, the angle that the player is already at on the yaw, and then 0 on the Z because it's 2D and you don't need that at all. So this basically says look at what the player is already at on Y, but make sure that the X is always 10. And that achieves the you can't look up and down, and but you can and do still turn around. So the next thing is how the stick works. And so the stick entity, it knows that it's a prop and not a player. So I'm going to be able to set its angle and set its position. Sorry, right. So how this works is these player eye angles, it takes the player eye angles and sets it to those angles, and this here is to compensate for the fact that the prop would normally be, so as you can see here, the 90 tells it to be pointing straight forward out from where the player is aiming, rather than where it would naturally be long ways. So that's just a correction to the prop itself, and this is what's responsible for keeping it at the player's angles. And then, likewise, the set position is player position, and I have this plus 10 vector on the Z, and that keeps it a little bit above the player's feet, so that it isn't, sticking into the ground, but it also isn't in his chest. It's 10 units above the player's feet, which is where the player's 0, 0, 0 is. So that takes care of the stick and the eye angles. And finally, we have how the WASD works, where it's kind of not sure what the word for it, handmade, that when the chip is activated, the player's natural WASD speed, so the amount of force that is being applied to them through their WASD naturally, is set to 0. So the game is still taking its WASD inputs as if, nothing else were different, just applying 0 force to where the player is aiming, effectively canceling it. And then, because I am not a very graceful coder, I simply have key forward, which would be W in this case, apply force 50 forward. Back is negative 50, left is 50 on this, negative 50 on that, and then if you're holding both down, 50, negative 50, so on and so forth for all of the different WASD combinations. And then finally, key jump. I needed it to put the player back down when they jumped, because I didn't, want jumping involved. So whenever they jump, the speed actually did not affect the jump, so I had to do this where it put another vector down to counteract that jump. And then I simply have it to where when the chip turns off, it sets the player's speed back to what it naturally would be, so that you have this smooth transition between top-down and not top-down. And that is the whole contraption. So I hope this very much shows, aptitude with camera, and just with having the mindset of having all of these gates, composing these vectors, adding values to them. So I hope that this demonstrates a bit of, yes, I understand what I am doing, I'm just unfortunately having to do it in another project.